Hello again, guys. Good morning. For this post, I'll help you solve this challenge from Splunk team, hosted in this cyberdefenders.org, which is named Boss of the SOC version 1. So CTF really is a nice way to hone your skills and sharpen your investigation or blue team skills because you don't get to see a full-blown compromise every day or breach. Mostly when you're working on the SOC, as I do, we typically handle or receive phishing incidents or scanning incidents and malware, but not really an APT level or ransomware level. Those happen once in a blue moon, so thankfully. Okay, with that out of the way, I'll be greeting you Happy New Year as well. So today's a new year later, so just be careful out there in the fireworks that you're using. Stay safe, do a social distancing, and God bless on the new year. Okay, let's start. So here we have the boss of the SOC, how to set up guide. So first, in order to really perform the CTF, you have to download the challenge. Of course, you have to register with the cyberdefenders.org and just unzip the virtual machine and then open it using your virtualization software like VirtualBox or VMware. So the password for the zip file is cyberdefenders.org, and the login to the VM is Vagrant and Vagrant. Username and password is the same. Then simply grab the IP address and then browse using this URL. And you're good to go. Okay, so as for the challenge, this is divided in two parts. So first we have the APT scenario, namely Poison Ivy AP. Poison Ivy is our APT. So this is the challenge, description of the challenge. And then the second half, scenario 2, is we will tackle how to investigate a ransomware. Okay, so let's go to the challenge questions to start off with the scenario 1. So the first question, so I've answered it all, but later I'll be guiding you through the actual Splunk console how to. So let's start with a very simple question, number 1. So it's asking us, what is the name of the company that makes the software that you are using for this competition? So really, since this is made by Splunk team, so the answer is obviously Splunk. Okay, congrats. You made the number 1 question. As for number two, let me just zoom this a little. It says here, what is the likely IP address of someone from Poison Ivy Group scanning I'm really not Batman.com web server for web application vulnerabilities? So if we look at the hint, oh, the hint goes like this. So here's the hint for this. So there, let's search. Okay, so we will narrow our search using this web server domain. So let's go to the Splunk console. By the way, this is the query for checking out the available indices in this Splunk sample dataset from cyberdefenders.org challenge. So obviously we will be focusing on this one, the abbreviation of boss of the SOC version 1, bots B1. Okay, so let's do that. So let's limit and narrow our search. Index equals B1. Then let's really just limit to I'm really not Batman.com. So let's do that. Okay, just paste it. It means that we will look into this index and the event should contain this string I'm really not batman.com. Just press enter to do a search. Okay, so since we are looking for the scanner, vulnerability scanner, we will okay, we will first we will check the aggregated source IPs, meaning the IPs going inbound the web server in question, which is umbrella.batman.com. So here, let's see the parse fields in this left section. So we'll be focusing on the source IP or SRC underscore IP. So here, there are three aggregated and parsed source IPs. So we have here the 40.80, the 192.168, and the 23.22. So if we will look at this, definitely we will exclude this 192.168 because this is internal IP. So not really a vulnerability scanner from a threat actor, third-party threat actor perspective. So we'll just have two possible candidates. And as we know, since we are looking for a vulnerability scanner, it's definitely noisy. So this one is really worth checking out first. So due to the high volume of count of inbound requests going to I'm really not batman.com. So to limit our search with just this source IP, simply click on this and it will be added to the query. So click that. So notice it automatically add the source IP in our query. And then let's do a check on one of the events. So okay, so let's do a raw text. And here we can see here that in this raw event, it's actually using the raw event. We can actually see right here. If you're familiar with web scanners, this is one of the vendor of web vulnerability scanner, Acunetics. So right there, it's a free edition of it. So if we'll do a search within these events, just simply by pressing Control F and then Acunetics. So you see a lot of hits showing this word Acunetics in this event. So you can see here the match events in our search. Of course, this is just a page one. We have a lot of page showing these events. Okay, so let's proceed to next question, number 3. So what company created the web vulnerability scanner? So definitely it's Acunetics, as we have seen from the number two events, right? So as we can see here, yeah, definitely Acunetics. Okay, and then let's proceed to the next. What content management system is I'm really not batman.com likely using? Okay, so to solve this, okay, let's check the request from the scanning IP address from previous question and inspect the fields related to the URL URI field for clues as to what CMS this is using. So let's do that. Let's do that. So using the same query from number 2. So here, let's check the URL URI fields. URL. Okay. So from here, we can already see a familiar and common CMS named Joomla. Okay, so for the number 5, this is the question. We're looking for the name of the file that defaced the I'mReallyNotBatman.com website. So to do this, let's first check the flow since this is already a defacement flow. So the source IP will really be the IP of the web server. That's what's defaced, which is I'mReallyNotBatman.com. So to do that, let's first search. So for this one, the query, this is really from the attacker to the web server. So for, based from this, we can get the target IP or the web server of the I'mReallyNotBatman.com, which will be parsed under destination IP. So definitely this will be that IP. Since this is a high volume, this is the one being scanned for vulnerability. So we will now be use this IP as the source or the client IP. Then let's check for the, so I'll just click this for now, and then let's check for the URL. So let's limit this. So now that we have the IP, let's change this. As I mentioned, since this is defacement, so the client now will be the web server fetching the defacement file from the attacker's machine or attacker's server. So let's do that. And then we have to do a count, do an additional. Okay, that's count by URL. One 68. There you go. So from here, based from the result, we can already see the suspicious one, which is the first one. The others are related to the CMS Joomla. But this one, as we can see, is from a suspicious domain named prankglass in a bracket .jumpingcrab.com, and it's fetching a JPEG file. Poison Ivy is coming for you, Batman.jpg. So there's our answer. The answer is that Poison Ivy is coming for you.jpg. Then for the question 6, so this attack used dynamic DNS to resolve the malicious IP. What is the FQDN associated with this attack? So definitely it's the prank glass in a bracket .jumpingcrab.com. Okay, so next question. So on the number 7, we are looking for the IP address wherein tied to Poison Ivy domains that are pre-staged to attack Wayne Enterprises. So that's the I'mRealNotBatman.com website. So to do that, let's reuse the query we have from number 2. So if you recall, this is our query, .batman.com. To check the IPs attacking our website or the I'mRealNotBatman.com, let's check again the source IP right here. So definitely this is the scanning IP, and we have here another attacking IP, 23.22.63.14. So let's copy that. Then let's pivot using virus total. So simply search there, search the IP, and we'll go to the relations tab, and then definitely we can see here There, poison ivy. And notice here, the prank glass in the bracket, the jumpingcrab.com. So there's your answer. So let's go to number 8. So here we're looking for an email address likely associated with Poison Ivy APT group. So to do that, we'll again use our pivoting skills. So we'll take this IOC and let's go to a pivoting website like ThreatCrowd. Then simply put and type the IP there, and it will resolve to you related intels or related infrastructure, IOCs, artifacts tied to that IP address. So if we look at here, okay, here is our IP address, and we're looking for a tied email address. So as you can see here, this one stands out. Okay, so let's go to number 9. We're looking for the IP address doing or attempting brute force password attack against the I'mReallyNotBatman.com. So again, we'll reuse our query before. So this is our initial query, but this time we'll focus more on the HTTP post method request, which is the method used for login. And then we'll just do a table. We'll do a table or a stats on the fields that we need. So particularly the form underscore data, which contains the credentials being used to log in. Okay, let's do that. So let's limit it first to HTTP. Then let's limit the method. So you can see here the method, HTTP method. So here, let's just limit it to post. So here's our query. Then as mentioned, we are interested in the form underscore data field, which contains your credentials. So to make it easier for us to see which IP is doing the brute force. So stats count by source IP, and then form underscore data. Okay, sorry. And the status. There we go. So here we can already see the suspect IP, which is 2322.63.114. And as you can see here in the form data, as mentioned, it's the field that contains the credentials being used for brute forcing. So here we can see that admin account is being brute forced with different passwords. So there, admin, password, you can see here the iteration of different passwords, starting from Arthur, Big Daddy, so forth and so on. Okay, so to our next question, number 10, what is the name of the executable uploaded by Poison IB? Plus include the file extension. So to do that, since we already know the IP of the web server, let us narrow down our query again to that IP, focusing on HTTP traffic, particularly on the multipart /form -data, commonly used for file upload requests. So let's do that. So to do that, so I'll just modify a few parameters. We'll now use the destination. Remember, this is the IP of the web server, 250.70, and then we'll just focus on the multipart form -data. So here we go, it's auto resolving, and then let's use head 1 to view to view that. Okay, so here we'll see we can already see here the file. The file name 3791.exe. So here's our answer. Hash of the executable uploaded. So executable hash of this one 3791.exe. Okay, so first let us search the available source type of this executable. So let's search for the source type that has ND5. So to do that, so let's limit our search again. So looking for 3791.exe hash, then ND5. So stats count by source type. So, so we only have sysmon. So let's use that query. Let's add that sysmon. So let's add that to our query. Source type equals. There you go. So based from the results, you can already see here the ND5 value. So here's our answer. And if you want to parse it, you can actually output it on the query itself, the ND5. So we'll use a parsing regex pattern. So to do that, we can add. So with this, you have to have a little bit background of regex. It's actually just a pattern matching using predefined sets of patterns. So for this one, we'll use the rex command, and then the field will be called the field where we will take the parsed data is the raw. So this underscore raw. Then here we'll specify portion of that raw text wherein we will take the data. So here, as you can see here, this is the data that we want. So at the start of the character, there's ND5 equals. So we will not take this. So we will use an inclusive. We will use an inclusive pattern. So this will only take the data inside that open and close parentheses, and then we'll use a positive, if I'm not mistaken, this is a positive look ahead regex pattern. Then we'll put in the name of the field that we want when it is parsed by Splunk. So this will make much more sense later. Then of course we have to use we have to match the whole string after the MD5 character, and then we can now use that parse field to output it on a table. So let's see if this works. Okay, there you go. Oh, I think I'm missing something. Command line. Oh no, we are looking only for the we need to narrow down this further. So if you can recall in the raw event later, the command line is actually just 3791.exe, so that we could really get the hash for that specific executable. Hmm. Okay. Okay. There you go. Okay. So let's proceed with number 12. So for this question, we are looking for the SHA-256 hash of this malware that was used by the Poison Ivy APT group for this attack. Okay, so recall that we have detected on number 7 the pre-stage IP address. So this one. So this one will use again our pivoting skills. So with the help of VirusTotal, first we have to search that IP, and then we'll go to the relations tab to see the related files. So here we have the communicating files and the files referring to this IP address. So communicating files are the files that communicate with this specific IP address, while files referring are the latest files where the IP address is found on the contents of that binary. So, so we'll just focus on this section, communicating files and files referring. So I'll just take this for example. So let's see this one, Miranda screensaver.exe. So simply click on it, and then since we are looking for the hash of the file 256, it can be found on the details tab. And as you can see, this is actually the answer. Okay, so for question 13, we are looking for the hex code associated with the customized malware that was found on question 12. So this one, it's actually, so the hint is it's not in Splunk. So the next section that we can really look into is the virus total. It's actually found in the community tab. It's actually a giveaway. So we can really see here, one of the users commented the hex code. So there goes your answer. So just type it, and then for the question 14, it says here one of Poison's IB stage domain has some disjointed unique WHOIS info. So for this one, will utilize again our pivoting skills. So let's do pivoting again using threat crowd. So simply search that staging IP is for the attack. And then we can see here the related domains hosted on the specific IP. So just give it a while to load. So here you go. So we'll look at the domains hosted on this IP. We can see these are the likes of WayneCorp PNC.com, WayneCorpInc.com, WayneCorp Inc.com, Wayne CRP Inc.com. So what we'll just have to do is do a WHOIS lookup on those domains hosted on this IP. Okay, so this is the actual WHOIS history lookup by Hoaxy. So again, let's use the WayneCorpInc.com to see the WHOIS history. From here, we are finding for a disjointed WHOIS info. So anything that stands out here, so there you can see this is a really not really a readable or discernible string. So this is a disjointed WHOIS info. So it says here we have to concatenate the two codes together and submit them a single answer. So just merge them and there's your answer. Let's go to question 15. So the question is, what was the first brute force password used? So to do this, we will focus on the, again, we'll focus on the same index, and then the web server, I'm really not batman.com. And as for the field, the common field that handles the credentials inputted is the form underscore data. So I'll show you for you to appreciate what I'm talking about. So let's do that again. So index equals what one, then we'll focus on the web server batman.com, and we just limit it to the source type HTTP events stream. We'll use this, and since this is the login, it's actually using a post method, so we'll limit also to HTTP post. And as I mentioned earlier, we're just interested on the events that has a credentials inputted on the form data. So this is actually the format that you can see. We'll use a wildcard username, asterisk, and then pass WD. And then, so let's search first. So here we have two events. So as I mentioned, as you can see here, the form data, it, it parses the username and the password. So to output the username and password in the query, we will parse it. So let's do that. So rex field form. Interested in parsing the form underscore data username. So this username equals is actually the string before the actual user, as you can see in the form underscore data a while ago. So user, and the one inside the parentheses is the actual data we are going to parse, and the user is the actual field name we are assigning to that user. So we want the whole word after that username equals string, then same for the password. So sorry, I'll just copy this one, save the time typing. Form data, now we are parsing the password. So the string before the password string is actually pass WD equals, and then we'll name that field, parse field PW, and then we want to output it on a table including the time, since we are looking for the first occurrence of the brute force. We'll get the time and the parsed username and the parsed password, and we are going to sort them by time. So there we go. Let's see if this works. Okay, so there. Oh, don't forget you have to adjust the sampling because this is aggregated 1:100 events. So do a no event sampling to really see all the events one by one. 1:1 data. So let's just give it time to load. And then as you can see here, let's see if this sort by time. So yeah, it's sort by time. It's oldest to latest. So there you go. We have the answer. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so next question. So we are looking for a password in the brute force attack that is actually a Coldplay song title. So, and for this one, we are looking for a 6-character word. So see here, it's yellow. So to do this, let's go back again to our Splunk. Okay, so first we gotta parse the passwords that are 6-character in length. So to do that, we will reuse the query we have from the previous question. So we no longer need the parsing of the usernames, and then just leave the password, and then next we'll evaluate the length. We're gonna use the eval function. Okay, let's assign a parameter. Let's assign parameter length keyword for that. Then length for the password. Then once we have evaluated that, we'll do a search. So search length keyword. We're interested for the 6-character strings. And then we'll do a stats count by password, and then let's table that table password. We no longer need to sort by time, so let's see if this works. Okay, it doesn't work. Oh, there it works. So here you can see we have 213 brute force password attempts that has 6-character length. So in order to investigate it thoroughly, we'll be using it, we'll be exporting it. So just click on export, and then of course we will bash it to the Coldplay song titles that has 6 characters. So I have here, I've searched what are those Coldplay songs that have 6 characters. So we really have just 1, 2, 3, 4, 5, 6. So this will be an easy bashing. And then once we have extracted it, so this is the raw extract we have here in the column A. And then I just did a VLOOKUP on those 6-character Coldplay song titles. And we have a hit here that was yellow. So we'll just use a VLOOKUP formula for the column B. Okay, so that's how I did it. There's actually can actually be looked up directly in Splunk, but I haven't really mastered that query yet. So maybe next time. Okay, so next question. We are looking for the correct password for admin access to the content management system on this web server. I'm really not batman.com. So to do that, so if we look at the hint, actually, so I'll show you. So here, the hint says, are there any other IP addresses submitting passwords? So that's what we're going to look in our query. So we'll just modify this a little bit. Post, then we are looking for the password. You can reuse that. We can reuse our query and just do a stats count by SRC source IP. So source IP are the source IP doing the brute force attack. Let's just give it a moment to load. Notice here, based from the hint, are there any other IP address doing the attack? So this is that IP address. 40.80.148.42. That's your answer. Oh, sorry, we're looking for the password. Then just dive on that event, and then recall that the credentials are parsed in the form_data field. So that's where we're going to look. Oh, it's taking a while to load. Okay, so let's look at the form_data. You can see here, the password used is Batman. Next, we are looking for the average password length used in the password brute force attempts. So we are asked to round it to the closest whole integer. So to do that, okay, let's go back to our Splunk. We'll reuse our previous query. Okay, this is good. So since we are already parsing the password, we will again evaluate its length. So let's do that. Length, then password. We're getting the length of the parse password. We'll do a stat. Get the average length, password length. Then we'll output this as average length field. And then we'll do a evaluation of the average count, which we will be rounding to a whole number. Round average len 0. Then we'll just output it to a table for easier view. So it's auto resolving now. So let's see if this works. Just give it a time to load. There. So let's see. Well, the answer is 6. And for our next question, how many seconds elapse between the brute force password, scan, identify the correct password, and the compromised login? So we're asked to round to 2 decimal place. So for this one, since we know the correct password used, we can try to compute the difference in time between those two attempts. So to do that, we can reuse this same password parsing. So we can use up to that second row. And then we will search, since we know the successful login, which is Batman, successful password used. So we will search for that string, Batman. And then we'll do a transaction to count the difference. And we'll evaluate the duration. Let's assign a dur parameter for that, and then we'll round it to 2 decimal. Duration to 2. Then I'll put it on a table for easier view. Let's see if this works. Okay, so there's your answer, 92.17. And we're down to the last question for the scenario 1. So we are asked how many unique passwords were attempted in the brute force attempt. So this is the answer. So to get that, let's go back. We will reuse the last 2 rows to parse the password. And then, since we are asked for a unique count, unique password attempts, so we'll use the dedupe function. So we'll dedupe the password parsed data, and then simply do a count on those after it was deduplicated. So by using stats count. 2. So there. So that's your answer, 412. Okay, so let's proceed to our scenario 2. So if you will recall, scenario 2 is actually a ransomware attack. So it starts with the question number 20. So we have here how many unique, 21, sorry. So what was the most likely IP address of this host name, WE8105 desk in August 24, 2016. Okay, so to do that, we will simply query the host name. So 8105 desk. Let's do a stats count by source IP. Okay. And of course, it will output so many hosts, but we are just asked to limit it to the August 24, 2016. So let's filter that time. Date range, August 24. Oh, let's do this. August 24, 2016. So let's do a full day of August 24. Oh, okay, date range between August 24, 2016, August 25, 2016. Okay, let's do that. Okay, so we are just limited to two possible answers. Oh, sorry. 1, 2, 3, 4. Four possible answers, but really this is more of a broadcast address. So three possible answers. The 192.168.2.50.100.70. You can try all those three, and the answer is this one. Okay, so next question. Among the Suricata signatures that detected the ransomware, server malware, so which has the fewest number of times? So we are looking for the signature ID. So to do that, let's go. Okay, let's use the index again. Index bots v1. Then there's actually a source type here. As you can see here, there's actually a source type specifically for Suricata. So we'll use that Suricata. And we'll use the server string to limit our search to the specific malware. So let's do that. From here, let's observe the parse fields here. There's actually a signature ID field auto parsed here. So simply click on it and see the aggregated results here. Oh, sorry. Signature ID. I think oh, sorry. This is not. This is actually the alert signature ID. So this one, and notice here the list count is this one, 2816763, and that's actually the answer. Okay, so next question, we are looking for the FQDN that the server ransomware attempts to connect with at the end of its encryption phase. So this is actually the answer. So to look for it, let's go back to our Splunk. So if you will recall, we have found the host name of the infected machine. So we'll limit that to that specific address. So this is that infected machine. And since we're looking for DNS, so there's actually a source type for that. So source type equals DNS. And let's exclude the most. Okay, so I'll just show you this first. The DNS query is actually parsed on the query field. So this one. And as you can see here, we have to really trim this down further by excluding the most common not malicious domains or queries. So the likes of asterisk.local and okay, let's limit it further. Not query. Let's use an end ARPA as we have seen earlier, and not query. Of course, Microsoft.com, and we are looking for the query that has a dot because as you have seen here, I'll show you again. There are queries that are just like this. It has no dot, so we don't know if this is really a domain, so or an encoded one. So we're looking for this format, and once we have that, let's do a stats count by query, and let's count them ascending. Sort, I mean sort by count. Right, so let's see what we have. So as you can see here, we already see the potential culprits. So disregarding the clean domains, we have two possible answers. So this one and this one. The others are related to Windows, Microsoft, Bing, and really a clean domain. And then we'll sort. We are looking for the domain connected to at the end of the encryption page. So let's sort it by time. So to do that, table time. Let's table it by time. Table time and query. Sort by time. Sort it by time and then descending order, meaning latest to oldest time. So the latest time is this one. So this is the answer, server Hydra. And then for the same query, this is actually related to the next question. So what was the first suspicious domain visited by the infected host WE8105 desk in August 24, 2016? So since we have only two culprit domains, so this is the earliest suspicious domain. So the answer is this one, solidarityproximate.org. Okay, so next question. So we are looking for the actual length of the BB script that was run by the malware. So the entire script is prepended by the name of the launching.exe. So meaning, since the BB script is actually long, so we are expecting really a huge or a large number of string. So we have here the answer. It's actually 4,000 plus characters. So to find that, let's go back again. So this one we will be we'll be utilizing our sysmon data. So let's find that source type. Oh, okay, just fix some. So let's type this again. So there. So this is the correct query. So notice here the lengths are being parsed now for the whole command line. And this is actually the answer. So this is the whole VB script appended to that executable being asked on the question. Okay, so question 26, we are looking for the name of the USB key inserted by Bob Smith. So if we all look at the Microsoft Docs, this is the actual registry path and keys involved for the USB. So we are interested on the friendly name key, which is the name you assigned to the USB. Notice when you format a USB, you will be assigning a name, and this is that it is stored in the friendly name key. Okay, so let's go now to the Splunk console to illustrate what I mean. So since we are interested on the registry key, let's limit our search to there, registry. And as I mentioned, we are interested in the friendly name key. So we'll search that. So we actually had just 2 events. And notice here, we actually have the registry value data as the parse field. So here's actually your answer. Run the underscore pre. So let's go to the next question. It says here Bob Smith's workstation was connected to a file server during the ransomware outbreak. So what is that IP address of the file server? So to do that, okay, so let's limit this one to SMB. Source SMB events. So we actually have a string for SMB. So notice here SMB. And we will do a stats. Oh, don't forget the pipe. Stats count by path. Okay, and as you can see here, sorry, we actually have a lot here. So we will be limiting this to the file server connected to by the infected machine. So we'll add another parameter here, source IP of the infected machine. Recall it's 192.168.250.100 in our earlier question. And can just narrow it down to just 12. So here we are interested on the actual file share path. So not the IPC dollar share. This is really common in most enterprise. And not the sysball as well, not the net logon used by AD. So we are interested in this one, /file share. The actual path is actually folder name named file share. And we have here another one, this one, and this one. And if you dig into the event, you'll actually notice that the IP address of WE90421 SRV is this one. So okay, for question 28 we have how many distinct PDFs did the ransomware encrypt on the remote file server? Okay, to get this amount or value 257, let's go back to Splunk. Okay, let's first probe. Let's first probe what are the source types that has this PDF file events, PDF value on their events or raw events. So to do that, let's search first the source type, and let's do a sort based on the count. Sort, sort, dash count. Okay, as we can see here, we get the most events on the win event log. So let's use that source type. Just click on it. Then, oh sorry, let's actually include that in our query. Win event log. Okay, just win event log, and then let's see, do a stats count based on destination IP. Then sort dash count again. Okay, as we can see here, we have two destination machines that has a PDF on the event. So we have 526 for the 9421 and just 2 on the 8105. And since we know that ransomware encrypts a lot of files, so this is probably the one we are interested in, the first one. So we'll add that to our query. Deft equals, okay, I'll just copy this. And we'll limit our search coming from the infected machine. Recall if this is this IP 250.100. Okay, let's remove this. Let's see what we got. Source type, destination, test. Okay, weird. Why is it not showing anything? Or perhaps I think this is case sensitive. There, it's case sensitive, the source address. So we have 525 events. Let's see the aggregated fields. We can actually see here a relative target name. See, here are the encrypted PDFs. So there's a lot actually, it's 100 plus. So we need to do a distinct count on these PDFs. So to do that, okay, let's just add a function stats distinct count using the DC function, then relative target name, and we will have the unique PDFs, encrypted PDFs. So we have 257 here, distinct PDFs. Okay, recall that in the earlier questions we use another query to arrive with a unique count or distinct count. So the alternate query for this to arrive in the same question is using the dedupe function. So we can actually use dedupe, and then relative name, and do a stats count, and we will arrive with the same answer. Moving on to our next question, 29. The BB script found in question 25 launches this file, 121214.tmp. We are asked to look for the parent process ID of this initial launch. So to do that, if you are familiar with BB script, what executable in Windows actually launches BB script? So if you are doing forensics, you have to be familiar that the executable that launches BB script are commonly C script or W script. So we will just limit. So the most common is really W script nowadays when you are investigating JavaScript malwares. So it's most common to see W script launching BBS scripts. So with that, we'll just limit it to the file or the executable in question and W script. So this will be our query. So just press enter and you can see that it will actually limit the results to just, okay, let's wait it for it to load. Did I get it right? 121, oh sorry, I have a typo, 121214. Notice it actually limits to just one event. And here in the raw we can really see if we look at the parse field, we can actually see the parent process ID being auto-parsed. And clicking on the value, you can see here the parent process ID is 3968. That's our answer. Then for the next question, we have the server ransomware encrypts files located in Bob Smith's Windows profile. So we are asked how many text files does it encrypt on Bob Smith Windows profile path. So to do that, let's go back. Okay, so for this one, we'll actually limit our search to what's B1, and recall this is Bob Smith's host name, and be focusing more on just Sysmon data. Sysmon, and for this one, if you would search this, okay, why is it not no results? Oh, I mistyped it. For this one, we'll actually focus more on the target file name. Target, it's actually not here, but let me just fine-tune this a little further. We're actually interested in the profile path of Bob Smith. So to do that, recall that in Splunk you have to do a escaping of backslash users when typing a path. Bob Smith, the Wayne for, and recall that we are looking for the number of text files encrypted. Trace the text, and let's do a stats on it. Since we are looking for a unique count, target file name. Okay, so case sensitive, let's be careful with that. casing, and there you go. The answer is 406. Recall that we have an alternate query for getting a unique count, so we can also solve this using dedupe, just like in the previous question. The function, you can do a stats count to give you the same answer. Okay, we're down to 2 questions. So for the next question, 31, the malware downloads a file that contains the server ransomware cryptocode. So we are asked to find the name of that file. So it's actually this one. It's a JPEG. So to find that, recall that we need to tie up all the pieces of evidence from earlier questions. So if you will recall, to actually find the malware for this one, the file name of the malware, we'll focus on the suricata or IPS events. So we'll limit our search to suricata events. And if you would recall, we need to limit it to the source IP of the infected machine, which is 192.168.250.100 from earlier questions. And if you would recall, the first suspicious domain the infected machine connected to is this one, solidarite.proxima.org. So I don't know if my pronunciation is right, so let's go back. Use that as another part of the query and do a search. From here, observe that in the parse fields on the left, you could actually find the HTTP URL, that URL field auto-parsed. From there, we can see the actual path or the file being downloaded from this suspicious domain. And that's our answer. And we are down to the last question. So thank you for staying with me to the end of this challenge. So we are asked, now that we know the name of the ransomware's encryptor file, what obfuscation technique does it likely use? So definitely that's steganography. So if you're not familiar with the steganography, so I'm having a hard time pronouncing it. Steganography is a technique of concealing message or files to another file or binary. So in this case, notice that the ransomware executable, which is an exe file or a really portable executable, was hidden on a .jpeg file. Thus, it is utilizing steganography. So that's it. Thank you very much. So I hope you find this challenge useful and stay tuned for more. So see you.